Okay. You can start soon.
Okay, perfect. Good evening, everyone. This is Dr. Abhijeet, and today we are going to discuss the lipid biochemistry part 2. So, you already know, guys, the Oracle has initiated a 21 days revision series live class for university exams, right? So, in this particular series, we are going to cover the most important questions or the most potent questions which I feel that are important for your upcoming prof exam. So these questions are prepared keeping in view the previous 10-year questions or yeah, the repeated ones. So I will be teaching you over here how to go through the question, how to write the answer, which points to be included in the answer, right? Whether it is of 10 marks, whether it is of 8 marks, 3 marks, 5 marks, 2 marks, right? So I will be revising the entire topic in a very crisp, concise, and conceptual manner, right? So yes, I will be revising the most important topics, right, in the form of question and answer format, right? So it is beneficial for everyone, the ones appearing for the university prof exams and the other ones which are appearing for the NEET PG or the INI CET exam or the FMG exam, right? So they can also avail the benefit while listening to this lecture. So the topic that I will be covering up today, I will be covering the impact of lipoproteins. I will be first discussing what are lipoproteins today, and then I will be discussing what is the impact on the heart, right? I will be discussing the role of eicosanoids, right, in inflammation and homeostasis. I will be discussing the synthesis of ketone bodies, and I will be discussing the no diabetic keto acidosis and all, right? I will be discussing, although I have discussed this omega-3 and omega-6 fatty acids yesterday only. So yes, I will be discussing the differences between the HDL and the LDL, the high density lipoprotein and the low density lipoprotein. I will be discussing the prostaglandins and their role in the body, and I will be discussing the impact of the trans fat in our body. Right. So these are the topics that I will be covering in the form of Q&A today in our lecture. Now, why guys we should choose Oracle? No, we already know we have the recorded classes for flexible learning. For the ones who are not attending the class live, they can always go on for the recorded version, which is available on the app. Otherwise, we are conducting the live classes daily from 6 p.m. to 10 p.m., right? We are conducting the live classes daily from 6 p.m. to 10 p.m. We are also, yes, we also have the recorded versions of the practical sessions, which are recorded by the expert faculty. So yes, guys, you can always go on for the recorded versions of these practical videos, which will help to boost your marks in your practical exams as well, right? Now, for the ones who are want to revise all the important topics in a very quick manner, so we have covered this. This is called as the Express Exam module, in which we have covered the entire biochemistry, the most important questions which we feel which can be asked in your upcoming exam under 20 hours, right? We in this express exam module we have told you how to go through the no questions, right? And yeah, write that. So we also have this hard copy book sets, which is now available at your doorstep, right? Anywhere in India, you can order this. And guys, in these are the basically the notes. I would not say the notes. Yeah, these are basically the question and answers, right? So basically, the notes are curated in the form of Q&A, where no, the entire topic is being explained in the form of question and answer, and that's what the requirement of the hour, right? So yes. So we have fun riddles, fun zones, MCQs, which are also included over here. Now we have the foundational classes for flexible learning, export instruction, right? For convenient revision, you can just go on for these foundational live, the recorded version, which is available on the app. We have the live classes, which are no, we are conducting daily between 6 p.m. to 10 p.m., right? We have the express exam module in which we are covering everything under 20 hours and we are teaching you how to write the answer in your exam, right? Now we also have one-to-one doubt clearing session, but you can always book an appointment with the team over here, right, with the respected faculty, and you can get all your doubts clear. Even in the live classes, you can automatically, ask your doubts in the comment section, and we would be happier to answer it, right? We have the hard copy notes book set, which you can order from any part of the India. And yes, we have the question bank that covers the question from basic to advanced level. Now, they cover the previous 10 to 15-year questions of any national institution examination, for example, NEET PG, INI-CET, FMG. They also cover MCQs from various university exams across India, right? So we have reduced the burden of you people to search questions everywhere. So everything is compiled and put it over here. So you can always practice these questions which are available after each and every topic, and you can test your knowledge accordingly, right? Practical sessions, I've already told you the practical videos are being recorded and available on the app. You can just go on for these practical videos, right? So the subscription plans, guys, we have the foundation plan, right? We have the advanced learning plan of 6 months. We have the complete learning plan of 12 months. And we have the ultimate MBBS plan of 4 years, right? And you can use my code Dr. Abhijeet 20 for additional discounts, right? Now, coming on to the impact of lipoproteins on cardiovascular health and disease. Now, first, guys, we are going to discuss first the topic. Yeah, what are lipoproteins? I will be first covering that. What are the different types of lipoproteins and what's their role on the heart diseases and all? So, remember, guys, when I say lipoprotein, remember it is a compound lipid with proteins. It is a compound lipid with proteins, right? It is lipid plus protein. Lipid plus protein. It is a compound lipid. Compound lipid, it is also called as complex lipids. We have already discussed it yesterday. Complex lipids. Now, complex lipids are nothing but fatty acid plus glycerol. Yes, plus the other group. Other group over here, it is the, yes, proteins. Other group, it is nothing but the proteins, right? Now, guys, what is now let us assume that this is a blood vessel. This is a blood vessel. Let it be artery, or and it can be vein as well, right? Now, if there is any particular lipid over here, now let us suppose that this is the lipid. Now, this lipid, it is alone not soluble in the blood. Alone not soluble in the blood, right? Now this lipid, it is bounded by certain proteins, right? It is bounded, or just maybe the zero one. It is bounded by certain proteins, and these proteins which are bounded with this lipid, right? So yes, these are the proteins. Now, if lipid is bounded to proteins, okay, lipid plus proteins, now this will help in the transportation of lipid in the blood. So I hope you understand the importance why the lipid alone cannot travel in the blood, right? So we need these proteins which are bounded with this lipid, and they help in taking the lipid from like one particular place to another, right? Now we have different lipoproteins. Just the concept which I have discussed. Yes, we have different lipoproteins. Now, different lipoproteins, guys, remember, the very first one that you have to remember, it is chylomicrons. Chylomicrons. Then we have very low density lipids or low density lipoproteins. Lipoproteins. This is called as VLDL, very low density lipoproteins. We have low density lipoproteins. We have low density lipoproteins, LDL. We have intermediate density lipoproteins. So it is called as IDL, right? We also have lipo, or let it be high density lipoproteins. High density lipoproteins. This is also called as HDL, right? And we also have, yes, lipoprotein X, and we have lipoprotein A. LPX is lipoprotein X, and we have lipoprotein A. So these are the various different lipoproteins that are found in our body. Now, now guys, let us first discuss about chylomicrons. Chylomicrons. Now guys, remember that these are the ones very important. The lipoproteins that carry exogenous. Now, when I say exogenous, it is from outside. Okay. These are the lipoproteins that carry exogenous, or it is called as the dietary triacylglycerol. Triglycerides. We have already discussed the triglycerides yesterday, right? The simple lipid, that is the fat from intestine to peripheral organs. From intestine to peripheral organs, right? Now these chylomicrons, remember, they have maximum size. So they are carrying the lipoproteins. Obviously, they are helping in transportation. So they are carrying exogenous triglycerides from intestine to the peripheral organ. That is again very important. Now these chylomicrons, guys, they have maximum size, and they have maximum lipid content, right? Maximum lipid content. Now, and remember, guys, these have the least protein content. Now, it is a lipoprotein. So obviously, it will be having lipid and protein. So it is having maximum lipid and it is having least protein content. Now, whenever there is maximum lipid, remember that it is always least density. Very important. Least density. Now, this density beta, it depends on the protein. More protein content, more density. So you just have to remember, if there is more protein content, then there is more density. More density, right? So yes. So the density term, basically like it is more corresponding to, or it is proportional to, the protein content. Remember, guys, it is having the maximum lipid content. It ultimately means that it will be having this maximum triacylglycerol. So it has maximum triacylglycerol. Okay. So yes, that is something you have to remember. Guys, we have this apolipoproteins, right, which are present in the chylomicrons. So yes, the apolipoprotein present in chylomicrons, very important, guys. Again, a very important MCQ that you have to remember, right? It is apo B48, right? So other which you can see over here, other major apolipoproteins are apolipoproteins, which you can see, it is ApoC2 and it is ApoE. It is ApoC2 or it is ApoE, right? So that is again, you can just have to like remember. Just a no. Now, guys, again, how they will impact this cardiovascular health, how they will impact the cardiovascular health. Now, guys, remember these chylomicrons have a very like a least effect, or they have a very less, just yes, they have a very less direct role, less direct role in yes in cardiovascular disease, that is the CVD, right? So yes, of course, guys, if the triacylglycerol levels are elevated, if there is increased triacylglycerol, right? So it is often seen with excess chylomicron activity can no cause this or disorder like atherosclerosis and all. We'll be coming on to that also, right? So that was regarding the chylomicrons. Now coming on to very low density lipids. The second one, we have very low density lipoproteins. This is called as VLDL. Now, this VLDL, it is basically assembled in liver. Very important MCQ again. It is assembled in liver, right? Again, an important MCQ, guys. It carries exogenous triacylglycerol from liver to peripheral organs. Very important. From liver to peripheral organs, right? So over here, the apolipoproteins which are present, apolipoproteins present are, so remember we have Apo B100, we have Apo C2, and we also have Apo E. So these are the three important points that you have to remember, right? So they are mainly transporting this, yes, triglycerides, right? The triacylglycerol, okay? And yes, you already know if there is elevated THE, it can lead to atherosclerosis. Atherosclerosis, yes, arterial plaque, right? So yes, if there is increased VLDL, guys, remember it is always a increased risk of cardiovascular disease. Increased risk of cardiovascular disease. Coming on to the very important one, that is the LDL. Yes, the third one, guys, that is the LDL, that is called as the low density lipoprotein. Low density lipoprotein. Now, this low density, it is basically formed from VLDL. It is formed from very low density lipoprotein, right? So how it is actually very low density lipoprotein will first form intermediate density lipoprotein, and this intermediate density lipoprotein will form the low density lipoprotein, right? Now this pathway, guys, from VLDL to IDL to LDL, it is called as this pathway. It is named as lipoprotein cascade pathway. It is called as lipoprotein cascade pathway. It is called as lipoprotein cascade pathway. So remember, guys, this VLDL, I mean, this LDL actually, it has maximum cholesterol. Very important. It has maximum cholesterol and cholesterol ester contents. Cholesterol ester contents. It has maximum cholesterol and cholesterol ester contents, right? Now the cholesterol present in LDL, cholesterol present in LDL, it is called as bad cholesterol. Again, very, very important. It is called as bad cholesterol. And the apolipoprotein over here, apolipoprotein over here, it is only B100, only B100. So yes, now LDL, it is often referred to as the bad cholesterol, the low density lipoprotein often referred to as the bad cholesterol. LDL carries cholesterol from the liver, okay, to the cells, right? So remember, what is the function, guys, that you have to remember? LDL, yes, carries lipids, or simply I would say the cholesterol from, yes, the liver to the cells, from liver to cells, right? High levels of LDL, if there is, now guys, remember, if there is increased LDL, yes, so they are associated with an increased risk of, obviously it's a bad cholesterol, so there is increased risk of cardiovascular disease, because excess LDL can accumulate in the walls of the arteries. For example, this is the artery, and this LDL, yes, this LDL can accumulate in the walls of the arteries, and often it will reduce the flow of the blood, right? It will reduce the flow of the blood, as they help in, no, reduce plaque. They help in forming the plaque, right? A process called as atherosclerosis, right? So LDL can, there is increased risk of CVD, that is the cardiovascular disease, okay? It accumulates, LDL accumulates in walls of the arteries, right, leading to the formation of plaques. And these plaques are nothing which will be leading to atherosclerosis. Atherosclerosis, right? So that is again very, very important that you have to remember. Now coming for like next, that is, yes, we have discussed LDL, VLDL, and we have discussed Kyom Microns. Now let us focus on, yes, the next one, that is the high density lipoprotein. High density lipoprotein, right? So remember, guys, it is formed from intestine and liver. Okay, it is formed from intestine and liver. Okay, now function of HDL is reverse cholesterol transport. Function of HDL is reverse cholesterol transport. It is also called as good cholesterol. It is also called as good cholesterol, right? It has maximum protein content. Okay, remember, it has maximum apoprotein content. Apoprotein content. It has least lipid content. Least lipid content. It has least size. It has least size. So these three, remember, it has maximum density. It has maximum density. Obviously, the protein content is more, so it is directly proportional to density. It has maximum density, right? Now, what is the function? It is helping in the reverse cholesterol transport. Over here, guys, just remember, it helps in, yes, it helps in remove excess cholesterol. Okay, removing the excess cholesterol from bloodstream, from the blood, okay, from the bloodstream, and transport it back to the liver, for excretion or recycling, right? So higher levels of HDL, if there is increased HDL, so remember it is protective against cardiovascular disease, okay, and they help in reducing the plaque buildup in the arteries. Whatever plaque is due to the cholesterol, they help in removing that cholesterol, and they help in taking that cholesterol back into the liver. So that's what is the reverse cholesterol transport, and anyways they are like helping in that, right? So that was regarding the very first question, right? The major ones which you can remember: the LDL, the HDL, the very low density lipoproteins, the chylomicrons, and its role in the cardiovascular health and disease, right? So that was regarding the first question. Coming on to the second one, discuss the role of eicosanoids in inflammation and homeostasis. Now, what are these eicosanoids, guys? First, just try to listen. Question number two, answer number two. It's a short answer type question. So remember, guys, whenever we talk about eicosanoids, now these are nothing, guys. These are nothing but they are derived from polyunsaturated fatty acids. Okay. Now, again, which polyunsaturated fatty acid? It is the arachidonic acid, right? Arachidonic acid. Right? So yes, arachidonic acid, you guys already know, it is released from the membrane phospholipids by the action of phospholipase A2. Now this arachidonic acid is metabolized by several enzymes into different classes of eicosanoids, right? So guys, if in short, if you just have to remember, so we have membrane phospholipids. Now these membrane phospholipids, basically they will release. No, they will release this arachidonic acid, right? Now, this arachidonic acid, basically this membrane phospholipid, it is releasing arachidonic acid with the help of the enzyme, yes, phospholipase A2. Phospholipase A2. Now, this arachidonic acid, it is metabolized by several enzymes into different classes of eicosanoids, right? We have COX, that is cyclooxygenase. We have LOX, lipooxygenase. We have cytochrome P450 enzymes, right? So remember, guys, if we talk about COX, it is cyclooxygenase, right? It produces prostaglandin. It produces prostaglandins, right? And thromboxans, very, very important. It produces prostaglandin and thromboxan. Now, lipooxygenase, it leads to the formation of lipooxygenase. Basically, it leads to the formation of leukotrienes, and lipoxans, right? Cytochrome P for 50. Okay, it releases certain acids, right? So it is epoxy icosastero. So remember, guys, it is epoxy icosanoic acid, right? Trinoic acid, okay, and other acids also, right? So remember, guys, what is the role of eicosanoids in inflammation? Now, you already know the prostaglandins. So remember, guys, if you already know the prostaglandins, so prostaglandins are basically they are produced mainly by COX-1, produced mainly by COX-1, that is cyclooxygenase 1, right? And COX-2 also, and COX-2 cyclooxygenase 2. So remember, guys, prostaglandin E2, basically they are potent vasodilators, very, very, very important. They are potent again, a very important MCQ. They are again potent vasodilators, right? They increase the blood flow, vasodilation, they increase blood flow to affected tissues, to affective tissues, and you already know, right? So this helps in muscular permeability, allowing immune cells and proteins to reach the site of injury. So yes, so that is something you have to remember. Now this PGE2 also induces pain. It induces pain. It is hyperalgesia, right? By sensitizing the nerve endings. So, right. So that is you have to remember. Then we have this, yes, leukotrienes, right? The leukotrienes. Now, guys, this leukotrienes or the LTs, it is produced by the action of 5 lipooxygenase or 5 LOX. So leukotrienes are basically LTB4 and LTC4. They are involved in recruiting white blood cells such as neutrophils to sites of infection or injury. To sites of infection or injury, right? So yes, even LTB4, remember, guys, it is a potent chemoattractant, right? That promotes the migration of neutrophils to the inflammatory sites, right? So that is you have to remember. So yes, eicosanoids also contribute to no homeostasis. For example, prostaglandin E2 and even prostaglandin I2, guys, prostacyclin are important for regulating the vascular tone, guys. They are important for regulating vascular tone, right? So PGI2 basically also promotes vasodilation. Now it helps in reducing blood pressure, right? And inhibiting platelet aggregation, right? So yes, again, the opposite one, that is thromboxane A2. It is also derived from arachidonic acid. It helps in vasoconstriction, guys. It helps in vasoconstriction and also platelet aggregation, right? Vasoconstriction and platelet aggregation, right? So yes, that is something you can remember. Coming on to the next one. Describe the metabolic pathways involved in synthesis of ketone bodies. That is general overview, guys. The general overview that you have to know about the ketone bodies. Let us just try to understand. Now, what is the concept of ketone bodies, guys? First, what is the concept of ketone bodies? Now, guys, you already know there is 1 to 4 hours after food. It is called as, yes, the fed state, right? When you have just taken the food, 4 to 16 hours, approximately 16 hours, it is early fasting. yes, 16 to 48 hours, it is late fasting. Then we have, yes, 2 to 5 days, that is starvation or prolonged fasting. Now, guys, 1 to 4 hour after food, you already know whatever the glucose has been stored in the form of glycogen. After like 4 hours, you're not having like any food. So in the early fasting, guys, remember we have glycogenolysis. We have glycogenolysis. Now remember, guys, the glycogen, it is broken down in these hours to provide glucose, to provide energy to the cells. Now 16 to 48 hours, we are not consuming any glucose from outside. So the body will try to make new glucose, and that is called as gluconeogenesis. Gluconeogenesis, right? And yes, 2 to 5 days we have like beta oxidation or ketone body synthesis, because all the substrate for gluconeogenesis from which the new glucose is basically formed in the body, we are not consuming it any glucose from outside, yet the body is trying to make glucose from other sources, from new substrate, and that also depletes after 48 hours. And in that case, the body will now undergo beta oxidation or ketone body synthesis. Now, ketone bodies are basically the metabolic fuel. It is the metabolic fuel for extrahepatic tissues. For extrahepatic tissues. Remember, guys, the brain basically needs ketone bodies in state of starvation. In state of starvation, remember, 20% it is from ketone bodies, now brain, and 80% it is still the glucose. Now, there are two types of ketosis, guys. I just wanted to discuss a little bit about this because this is a very important concept. There are two types. We have starvation ketosis, and we have diabetic ketoacidosis. Diabetic ketoacidosis. Remember, guys, in starvation ketosis, what is happening, guys? Glycogen depleted. Starvation, 2 to 5 days. Gluconeogenic substrate. Gluconeogenic means from other substrate, the new glucose is formed, right? The gluconeogenic substrate, it is also depleted, right? Beta oxidation will now produce the ketone bodies, right? Now you already know fatty acid. Okay, if we talk about, yes, this triacylglycerol, it will form fatty acids, right? Now fatty acid will undergo fatty acid oxidation, and this fatty acid oxidation, guys, will produce acetyl coenzyme A. Now this acetyl coenzyme A, either it will go into TCA cycle. No, but this acetyl coenzyme A cannot go into TCA cycle because oxaloacetate, a 4-carbon compound, it is already depleted in gluconeogenesis. Now this acetyl coenzyme A, unfortunately, has to go, sorry, has to go for the synthesis of ketone bodies. Ketone body synthesis, right? So that is one is starvation ketosis. Now we come on to diabetic ketoacidosis, right? Now, diabetic ketoacidosis, again the same thing, guys. You already know if this is a cell, the cell is having no glucose, right? We have this blood vessel. That is right. You already know the blood vessel, it is containing this glucose. The glucose is still not inside the cell, right? Now, cell will try to increase gluconeogenesis, right? Cell will try to increase gluconeogenesis because there is no glucose in the cell. Now, there is already depletion of oxaloacetate. This we are discussing about this. Yes, there is depletion of oxaloacetate, right? Body will now move on for the next source of energy, right? Now, even guys, you already know we have something called as insulin. Insulin inhibits hormone sensitive lipase. Hormone sensitive lipase, and that is yes, HSL, right? So if insulin is absent, diabetic condition is there, insulin is absent, or if the insulin is reduced. So what will be happening? This will become activated. The hormone sensitive lipase will become activated. Now this hormone sensitive lipase, it will act on triacylglycerol, which is present in the adipose tissue, Now this triacylglycerol will form fatty acid plus glycerol. Now, there is increased fatty acid, guys. Now it will go fatty acid oxidation, and this fatty acid will undergo, there will be increased acetyl coenzyme A, which is, yeah, again, the pathway for ketone body synthesis, right? So that is again, you have to remember. Now, if in general, I just want to tell you about the pathway, a general overview, guys, remember what will happen? Pathway of ketone body synthesis in beta oxidation, we have acetyl coenzyme A, right? Now, remember this acetyl coenzyme A will be combining with this acetyl coenzyme A n number of times to form, let us suppose two acetyl coenzyme A are combining. It will form acetyl coenzyme A. That is a 4-carbon compound. We have taken acetyl coenzyme A, 2-carbon compound, and we are taking acetyl coenzyme A once again. It is 2 plus 2, 4, acetoacetyl coenzyme A. This acetoacetyl coenzyme A, again we are adding acetyl coenzyme A. With the help of enzyme HMG-CoA synthase, and it will form HMG-CoA, hydroxymethyl glutaryl coenzyme A. Nothing to remember as such right now. Now this HMG-CoA will undergo lysis, okay? Will acetyl coenzyme A coming out. We have an enzyme called as HMG-CoA lyase, and it will form acetoacetate. Acetoacetate. So yes, remember acetoacetate, guys, it is the primary ketone body. Again, a very important MCQ. It is a primary ketone body. It's a very important MCQ, right? This acetoacetate will again bifurcate and form acetone and beta hydroxybutyrate. Now, acetone, it is a secondary ketone body. Along with this, the beta hydroxybutyrate, it is also a secondary ketone body. Right? It is also a secondary ketone body. So that's a general overview that we have to remember, right? Coming on to the next question, guys. Yes, significance of omega-3 and omega-6 fatty acids. We have already discussed this in, yes, the last class, right? So if we talk about omega-3 fatty acids and omega-6, in short, I'm just discussing it, guys, right now. So examples over here are alpha linolenic acid. Yes, we have timnodenic acid. We have cervonic acid. Now, what does this do? This decreases inflammation, decreases cardiovascular risk. Now, it decreases risk of attention deficit hypersensitivity disorder. It decreases risk of rheumatoid arthritis. It decreases risk of Alzheimer's disease, and it also decreases risk of cancers. Now coming on to omega-6 fatty acid. Omega-6 fatty acid, guys, you already know. We have gamma linolenic acid, gamma linolenic acid. We have linoleic acid, linoleic acid. We have arachidonic acid. Now, when I say arachidonic, we are actually talking about prostaglandins and leukotrienes. And we have discussed prostaglandins and leukotrienes in detail. Prostaglandins and leukotrienes in detail. So they are the mediators of inflammation. They are the mediators of inflammation, right? So it increases thrombosis also, right? Can relate to cardiovascular risk, right? So sulfonic acid or docosahexaenoic acid, right? So it is a omega-3 fatty acid also, the sulfonic acid, or it is also called as docosahexaenoic acid. It is basically a omega-3 fatty acid present in fish oil or breast milk, right? Remember, it is very, very important. It is needed for infant or fetal brain development. Fetal brain development. It is needed for development of retina. Again, a very important MCQ. It is needed for development of retina. It is needed for development of retina. Okay. So yes, if DHA or docosahexaenoic acid it is decreases in the antenatal period, in the pregnancy period, guys, it will have a risk. The baby will have a risk for the development of retinitis pigmentosa. Okay, so this sulfonic acid can cross the placenta very easily. So can pass transplacentally, can pass transplacentally, right, and reach fetal circulation and reach fetal circulation, right? That is about this, right? Next question. Difference between HDL and LDL cholesterol. I've already told you the good and the bad cholesterol. We have already discussed in the starting of the class. Prostaglandins and their role in the body. I've already discussed this as well, right? Now coming on to the health implications of trans fat. Coming on to the health implications of the trans fat. And guys, remember, yes, over here, just the important ones that you have to remember. We have artificial and natural trans fat. So basically, if we talk about trans fat, it is basically two types, right? Now, trans fat basically means unsaturated fat. It means unsaturated fat, right? So yes, that has been chemically altered through a process called as hydrogenation. Okay, so it is the hydrogenation, right, which turns liquid vegetable oils into solid fats, right? So basically, the fat becomes more stable and extends the shelf life of processed food. So they have negative health implications also. So we have trans fat divided into artificial and natural trans fat. Natural trans fat. So in the artificial, remember we have, yes, cookies or cakes or pastries, all the bakery items, right? The chips, the crackers, the fried food, the fast food, the momos, right? The natural trans fat, basically some amount of trans fat are found naturally in the meat and dairy products of ruminant animals like cows and sheep. So that is, you have to remember. Now, what are the health implications, guys? They increase risk of cardiovascular disease, right? Cardiovascular disease. It helps in increase LDL. LDL means the bad cholesterol. We have already discussed the low density lipoprotein. The low density lipoprotein, it helps in the formation of arterial plaques, leading to a decreased blood flow, right? So yes, it in turn decreases HDL. That is the bad, the good cholesterol. That is the good cholesterol, right? It promotes inflammation. It promotes inflammation. It tries to increase the inflammation in the body, which is another contributor of heart disease. Now, this trans fat also tries to increase the risk of type 2 diabetes mellitus. We have two types of diabetes mellitus, type 1 and type 2. They have increased risk of type 2 diabetes mellitus, right? Even the weight gain, obesity, right? So it helps, it basically accumulates in the abdominal wall and yes, abdominal fat accumulation, right? So that is you can just remember. That is the health implication of trans fat. So that was regarding today's lecture. These are the various social media handles that you can follow for the upcoming updates of the future classes. Thank you so much.